Pontiac began as an adjunct to the Oakland division of the General Motors line of automobiles in 1926. Pontiac successfully competed against more expensive four-cylinder models with their inline flathead six-cylinder engines. After outselling Oakland, Pontiac became the sole survivor of the two by 1932. In addition to the inline six, Pontiac also had an inline 8 by 1933. These two engines were used through 1954, when Pontiac unveiled its V8 in 1955. From 1955 to 1981 the Pontiac division of General Motors manufactured its own engines, distinct from Buick, Cadillac, Chevrolet, or Oldsmobile. Displacement began at 287 cubic inches and grew as large as 455 cu-in. By 1970, Pontiac engines were used in its U.S. market cars. Canadian-built Pontiac automobiles generally used Chevrolet engines. From 1955 through 1959, the Pontiac V8 was also used in some GMC pickup trucks. History: the development of Pontiac's V8 dates back to 1946, when engineers began considering new engine designs for post-war cars. Despite these experiments, the division's conservative management saw no immediate need to replace the Pontiac's straight-eight engine, which had served well since 1933. When Robert Critchfield took over as general manager in 1952, however, he launched an ambitious plan to move Pontiac into the upscale, mid-range market segment occupied by Oldsmobile, and that demanded V8 power. The development of the new engine was fast-tracked, but since its relatively late development let it take advantage of the experience gained in the Oldsmobile V8 engine and Cadillac V8 engine, it was remarkably free of teething problems. The main innovation of the Pontiac engine was the stamped rocker arms system, which had been devised by Pontiac engineer Clayton Leach in 1948. At the request of Ed Cole, general manager of Chevrolet, the layout was also used by the Chevrolet V8 released in 1955, an exception to the customary GM policy of allowing a division 1 year of exclusive use of an internally developed advance. Federal emissions standards and the drive towards corporate engines shared among all GM divisions led to the progressive demise of the Pontiac V8 through the late 1970s. The last true Pontiac V8s, a 265 cubic inches and a 301 cubic inches, ended production in 1981. Pontiac also used the Oakland V8 engine in 1932 only. During 1951 and 1952, Pontiac had 23 1953 model production prototypes running tests on the GM Proving Grounds. These 23 cars were equipped with the new 287 V8 engine. Pontiac planned to produce the 1953 models with a V8, but Buick and Oldsmobile feared a sizable loss in customers if they had to compete with Pontiac having a new V8 engine. After hearing from Buick and Oldsmobile, GM's board of directors ordered Pontiac to delay the V8 introduction until 1955. Pontiac's V8 development that started in 1946 was a 269 cubic inch L-head design. The 287 cubic inches overhead design started in 1949. Pontiac engineers tested their 269 V8 in 1949 or 1950 against a downsized Olds Rocket V8 overhead engine. The Olds engine was a 303 cubic inches, Pontiac reduced the size to 270 cubic inches for testing against the 269 engine. The test results showed Pontiac that a L-head engine couldn't compete with the overhead engines. Design: the 1955 up Pontiac V8 was an overhead valve engine with wedged combustion chambers. It used cast-iron cylinder heads and a cast-iron block. An innovative design feature was mounting the rocker arms on ball pivots on studs set into the cylinder head, rather than using a separate rocker shaft. This allowed more consistent valve action with less weight than a conventional shaft. It was also cheaper to build than a rocker shaft. This Pontiac patented technology was immediately handed to the Chevrolet division for their first post-war V8, which appeared the same year. This handing over Pontiac's valve train invention violated GM's rule for a division having a one model year exclusivity, but alas, Ed Cole at Chevrolet got his way. All used 6.625 in connecting rods. All Pontiac V8s from 1955 to 1959 were reverse-cooled, known as the Gusher cooling system. It was removed from the design for the 1960 model year because designers moved the generator and the power steering pump from atop the front of the engine down to the front of the heads to accommodate a lower hood line. However, the 1959 389 engines had the generator in front of the heads with reverse flow cooling still in use. This suggests that the cost of the reverse cooling was the reason for the change to equal flow cooling. Most iterations had an overall length of 28.25 inches, an overall width of 27 in, and a height of 31 in, 686 mm, 787 mm. Dry weight ranged from 590 pounds to 650 pounds, depending on displacement and year. Most Pontiac engines were painted light blue. The 1958 370 inches engine and the 1959 Euro 60 389 version was named the Tempest V8 and changed in '61 to the Trophy V8. Pontiac in the 1950s was one of a few U.S. manufacturers which did not regularly identify its engine names and sizes with air cleaner or valve cover decals. Engine development, small journal engines. 287 The V8 engine was introduced for the 1955 model year as the Strato Streak. Not long before the model year introduction, Pontiac management decided that the entire line would be V8 powered. This was based on results of over 1 million test miles, which was unheard of at the time. The 287 was an over-square engine with a bore of 3.75 in and a stroke of 3.25 in. For a total displacement of 287.2 cubic inches. Compression ratio was a modest 8.001, with valve diameters of 1.781 in and 1.500 in. It was rated 180 horsepower at 4,600 RPMs and 264 lb-ft at 2,400 RPMs with a two-barrel carburetor, 200 horsepower at 4,600 RPMs and 278 lb-ft at 2,800 RPMs with the four-barrel carburetor. 316 For 1956 the V8 was bored out to 315 a 16 in, increasing displacement to 316.6 cubic inches. It was offered in the following forms, with manual transmission, two-barrel carburetor, 7.91 compression, 192 horsepower at 4,400 RPMs, 297 lb-ft at 2,800 RPMs, four-barrel carburetor, 8.91 compression, 216 horsepower at 4,800 RPMs, 315 lb-ft at 2,800 RPMs, with hydromatic, two-barrel carburetor, 8.91 compression, 205 horsepower at 4,600 RPMs, 294 lb-ft at 2,600 RPMs. Four-barrel carburetor, 8.91 compression, 227 horsepower at 4,800 RPMs, 312 lb-ft at 3,000 RPMs, two four-barrel carburetors, 10.51 compression, 285 horsepower at 5,100 RPMs, 330 lb-ft at 2,600 RPMs. 347 For 1957 the V8 stroke was increased to 3.9 a 16 in, for a displacement of 347 cubic inches. For the first time, Pontiac offered tri-power, 3 two-barrel carburetors with a sequential linkage. Power ratings increased accordingly, with manual transmission, two-barrel carburetor, 8.51 compression, 227 horsepower at 4,600 RPMs, 333 lb-ft at 2,300 RPMs, four-barrel carburetor, 10.1 compression, 244 horsepower at 4,800 RPMs, 350 lb-ft at 2,600 RPMs, with hydromatic, two-barrel carburetor, 10.01 compression, 244 horsepower at 4,800 RPMs, 350 lb-ft at 2,600 RPMs, four-barrel carburetor. 10.01 compression, 270 horsepower at 4,800 RPMs, 359 lb-ft at 2,900 RPMs, three two-barrel carburetors, 10.001 compression, 290 horsepower at 5,000 rpms, 375 lb-ft at 2,800 rpms. Several dealer-installed camshafts were optional to increase power further to 317 horsepower, which was seen on the hood of the 1957 Daytona Grand National winning car driven by Cotton Owens. Standard only for the Pontiac Bonneville was Pontiac's first ever fuel injection system. A mechanical system built by Rochester, it was similar in principle, but not identical, to the contemporary Chevrolet Fuili. Pontiac did not release official power ratings for this engine, saying only that it had more than 300 horsepower. Contemporary road tests suggest that it was actually somewhat inferior to the tri-power engines, although it did have better fuel economy. Only 630 Bonnevilles were produced for 1957, all of them fuel-injected. 370 For 1958 the V8's bore was increased again to 4.116 in, increasing displacement to 369.4 cubic inches. The engine is now called the Tempest V8 and will be called this until the end of 1960. The fuel-injected engine was now an option on any Pontiac model, carrying a staggering price tag of $500. It was rated at 310 horsepower at 4,800 rpms and 400 lb-ft at 3,000 rpms on 10.51 compression. Only about 400 were produced before the fuel injection system was quietly dropped. 389 For 1959 the V8 stroke was increased to 3.75 in, raising displacement to 388.9 cubic inches. This was the beginning of factory-supplied performance items such as 4-bolt main bearings and windage trays to reduce friction from crankcase oil. The 389 would remain the standard Pontiac V8 engine through 1966, offered in a bewildering variety of outputs ranging from 215 to 368 horsepower. The 389 was the standard engine for the Pontiac GTO through 1966. Beginning in 1961 the Pontiac V8 is now called the Trophy V8, due to its many victories in racing. 326 In 1963 Pontiac dropped the Buick division-built 215 aluminum V8 it had offered on the Pontiac Tempest and replaced it with a small-bore version of the standard 389 Pontiac V8. It shared the 389's 3.75-in stroke, but its bore was 3.78 in for a displacement of 336 cid. It was rated at 250 horsepower with 8.61 compression and 260 horsepower at 10.251 compression. Both used a single two-barrel carburetor. In 1964 when the new A-body intermediates came out there was a new corporate engine size limitation to anything less than 330 cubic inches and so the 326 bore size was reduced to 3.72 giving a true 326 cu-in. The 326 subsequently became the optional V8 engine for Tempests, and later the Pontiac Firebird, through 1967. A higher output version was offered, called the 326HO. It had a 4-barrel carburetor, dual exhaust, and higher compression, and was good for 280 horsepower for 1963 1964 and 285 horsepower for 1965 to 1966 and the final year, 1967. 400 For 1967, Pontiac introduced the 400 cubic inches. The 400 V8 was essentially a bored-out 389 with 4.120-inch bore and 3.75-inch stroke 400.4 cubic inches. It replaced the 389 in 1967 and remained in production through the 1978 model year. The 1979 cars with a 400 had an engine produced in 1978. The 400 was a popular performance option for many of Pontiac's cars. The 400 produces a good balance of low-end torque and higher RPM power when used with a 4-barrel carburetor or other high airflow components. In 1967, the cylinder head design was improved for all engines. The valve angle was reduced from 20 degrees to 14 degrees for better breathing. 1967 was the last year for closed-chambered heads. The 670 head was a 1967 only casting. and the last PMD head to have a closed chamber. Pontiac went to open-chambered heads in 1967 to improve power, engine breathing and reduce emissions. The valve size increased as well, to 2.11 inches intake and 1.77 exhaust valves on high-performance heads. Low-performance and two-barrel applications got 1.96 inches intake and 1.66 exhaust valves and pressed-in rocker arm studs. 350 In 1968 the 326 was replaced by the 350, which used a 3.875 in bore and 3.75 in stroke for a total displacement of 354.74 cubic inches or 355 inches, although it was still called a 350. This engine was offered in both 2-barrels and 4-barrel variations similar to the previous 326 engine. In 1968 an HO option was available in the Tempest, and Firebirds that were rated at 320 horsepower. This engine was also offered in 1969 along with a second HO version. The later 350 HO was rated at 330 horsepower, and was equipped with the 400 CI large valve heads and the 400 HO camshaft. In 1974 it was used in the GTO and was rated at 200 horsepower. 303 In 1969, Pontiac unveiled its Trans Am model Firebird, and since racing rules required a sub-305 SID engine, Pontiac unveiled the 303 for racing models only, never available to the public. Bore and stroke were 4.121 inches x 2.840, for 303.63 cubic inches. It was rated at 475 horsepower. If you were comparing bore to the 400, Pontiac used a 4.121 bore, not 4.125, which was the Chevy 402. 301 The 301.6 cubic inches 301 was offered from 1977 to 1981 and also installed in other GM cars during those years. The 301 had a 4 in bore and 3.00 in stroke. Based in part on designs for the short deck 303 cubic inches engine designed for the 1970 racing season, it had a shorter deck than the big V8, and used thin wall castings to reduce weight. The crankshafts were also unique in the fact that they featured only 2 counterweights instead of the usual 5, and also featured lightened connecting rod journals. This resulted in a lightweight design weighing less than the Chevrolet small block V8. Power output ranged from 135 horsepower to 170 horsepower. The heads were a new design featuring Siamese intake ports. The short deck block and different intake ports also required the design of a new intake manifold. The Pontiac 301 EC version offered in 1981 produced 155 horsepower and 245 lb-ft. Although it's rumored that the actual HP was closer to 170 horsepower. The 1980 301 Turbo was rated at 210 horsepower at 4,400 RPMs and 345 lb-ft at 2,800 RPMs. The 1981 301 Turbo gained the electronic controls with an O2 sensor, feedback ECM and E4ME quadrajet, providing a slight reduction in output to 205 horsepower and 340 lb-ft. Although it is much different than the original 1955 vintage Pontiac V8 power plant, the 301 has the distinction of being the last true Pontiac V8 engine, as Pontiac ceased production of these engines effective April 1, 1981. From 1977 to 1981 there were 4 distinct 301 versions, 301 2-barrel, 301 4-barrel, 301 4-barrel HO or EC, and the 301 Turbo, with the 5th van digit being a T. For 1981 model year vehicles, the engine codes are the 8th digit of the van. The 2-barrel version was last offered in 1979. The 4-barrel version was available from 1978 to 1981 and the turbo version was available in 1980 and 1981 only. The 301 Turbo was unique in that it had a beefier block than the 1977 Euro 79 versions, a very mild camshaft with .350 in lift and 250 degrees gross duration, a 60 psi oil pump to ensure adequate oil to the oil-cooled Garrett TB0305 turbocharger, a rolled fillet crankshaft, a fully baffled oil pan, and a specific 800 CFM quadrajet carburetor. This had extra-rich DX secondary metering rods and a remote vacuum source for the primary metering rod enrichment circuit to allow the power enrichment vacuum regulator to release the primary metering rods to move to the up position anytime during boosted conditions. This was to ensure there was enough fuel to cool the cast offset dished pistons. Boost was wastegate limited to 9 psi. The 301 turbo package mandated air conditioning, THM 350 non-lockup automatic transmission, and 3.08 rear axle gearing. The 301 turbo was limited to Trans Am and Formula Firebird production only, although some literature has indicated that the 301 turbo may have found its way into the Chevrolet Camaro Z28. GM's parts books do list the turbo engine for the Camaro. 265 based on the same short deck as the 301, the 265.1 cubic inches was offered only in 1980 and 1981, and featured a smaller bore of 3.75 in coupled with the same 3.00 in stroke of the 301. It produced 135 horsepower. Engine development, large journal engines. 421 introduced in 1961 as a dealer-installed Super Duty option that had dual 4 barrels, the 389 was bored to 4.3 or 32 inches and stroked to 4 in for a displacement of 421.19 qin, and also featured larger 3.25 in main journals. Unlike previous enlargements of this engine, it did not replace the 389. The 421 SD became factory-installed in 1962 and in 1963 a street version became available from the factory with a 4-barrel or tri-power carburation. The Super Duty versions of this engine were extensively used in NASCAR stock car racing and drag racing competition. The 421 also marked the end of the option for a forged steel crankshaft. The Armor steel cast crankshaft was the standard crankshaft of the entire Pontiac V8 line until 1967. While Armor steel was no more than a fancy name for a hardened cast iron unit, it did refer to the locking ball as opposed to the flaking type cast iron found in other engines. In 1967, Pontiac, out of concerns the public misunderstood the engineering terms, went to a nodular cast iron named crankshaft, which they used until 1975. 428 In 1967 the 421 was bored to 4.12. This gave a displacement of 426.61 CID or a 427. The 428 had the same 4 inches stroke as the 421, and was produced from 1967 to 1969. This engine produced 360 horsepower and 376 horsepower in 1967, 375 horsepower and 390 horsepower in 1968 and 360 HP, 370 horsepower and 390 horsepower in 1969. The crankshaft in the 428 also had a end cast on them as opposed to the 421's Armor steel. In 1969, Pontiac also used a revised crankshaft out of a pearlitic malleable iron, although it still used the N casting letter. This new material had stronger alloys in the iron. All 428 engines were factory-installed in large cars only. However, there were a few dealers that would install a 428 in a customer's GTO or Firebird for higher power levels. It was replaced by the 455 for the 1970 model year. 455 for 1970 through 1976, the 428 bore was expanded 0.030 inches to 4.15 inches, combined with a 4.21 inches stroke, yielding 455.34 CID. Oldsmobile and Buick also had 455-inch engines about the same time. For the 1970 model year, variants of the engine became available on all full-size Pontiacs, the Grand Prix, and for the first time as the 455HO in the Pontiac GTO, as GM lifted its restrictions on the use of engines larger than 400 cubic inches in mid-sized cars. The Pontiac V8 design differs from most other manufacturers' designs in that the external dimensions of each engine, from 326 to 455 cubic inches displacement, is identical. The displacement is determined internally with changes to the bore and stroke. Therefore, there is no small block Pontiac engine, in fact the same connecting rod length with the exceptions of the later short deck 301 and 265. The 455 was used through 1976. The 455, with its under-square dimensions, emphasized torque over horsepower, and though advertised as less powerful than some high-performance iterations of the 400, it had a torque rating of 500 feet per pounds, 55 more foot-per-pounds of torque than the 1970 performance 400s. The horsepower ratings of this era were often dubious, with engines rated higher or lower in output for advertising, political, or insurance purposes. Per Pontiac's sales brochure, the 1970 455, for example, had similar parts to the higher-rated Ram Air 366 horsepower 400 cubic inches, including the same 288/302 camshaft, yet was only rated at 360 horsepower. The 1970 Grand Prix with the same specification 455 was rated at 370 horsepower. For 1971 Pontiac introduced another high-output version with standard internal parts, a reinforced block with 4-bolt main bearing caps, and improved cylinder head design with 1/8 inch taller intake ports and special round exhaust ports for better breathing, making some 335 horsepower per 224 kilowatts, but this was an extremely rare engine. In 1973, a further refined and even stronger version, the Super Duty engine was introduced with only 310 horsepower per 231 kilowatts using a similar camshaft specifications to the Ram Air 400. The 455 SD used round-port cylinder heads similar to those used on the 1971 and 1972 455 HO, with specific LS2 intake and cast-iron exhaust header manifolds. Still, it was the strongest American engine offered that year. Its power was achieved through bending of EPA emissions testing procedures, which led engineers to detune the engine to 290 horsepower via a camshaft change to the same profile used in the early RA3 400 engines for mid-1973 and 1974, after which point it was discontinued. While an evolution of the RA4 and HO engine designs, the 455 SD was a much improved engine. In addition to the more refined cylinder heads, block casting reinforcements in the lifter-galleon main bearing oil pan rail area along with the addition of forged connecting rods with larger 7 or 16-inch diameter bolts, the SD was made with a provision for dry sump oiling from the factory. This truly was a racing engine, detuned for use in passenger cars. Ram Air, while not officially called the Ram Air I when it was issued, it was indeed the first in a series of Ram Air V8 engines from Pontiac. This engine was installed in the 1967 GTO Firebird as the top-of-the-line option and at 360 horsepower, it was the most advanced 400 in the line. This carried the 744 301/313 camshaft, as opposed to the HO cam which had less duration and overlap. It also had the famous cast-iron headers, which were much better at reducing back pressure than the regular manifolds. The cast 670 heads had taller valve spring heights than the standard D-port heads, making these heads unique. Ram Air 2 In 1968, Pontiac manufactured the Ram Air 2 which was a 400 cubic inch motor. In GTO trim the factory rated the car at 366 horsepower/445 TQ and only 340 horsepower/430 TQ in the Firebird despite the fact that the engines were identical. The Ram Air 2 was the first engine that incorporated Pontiac's legendary round-port head design in a production vehicle, however the intake port was the same as other D-port heads, leaving a head which exhaust port could nearly match the intake at high valve lifts. The Ram Air 2 also incorporated the first computer-designed camshaft. This camshaft sported a wild 308/320 degree duration with 0.470 inch lift. This same camshaft was also used in Pontiac's 1969 and 1970 RA4 production cars. The Ram Air 2, when outfitted in the lightweight 1968 Firebird, has produced some of the fastest one-quarter-mile times of the muscle car era. In recent years, under the pure stock drag racing format, Ram Air 2 Firebirds have consistently posted ETs in the low to mid-12-second range. No production Pontiac before or since has run times lower. Without question, the RA2 was one of Pontiac's most impressive factory offerings. Ram Air 3 The Ram Air 3 was the base engine in the Judge series of the GTO in 1969 and 1970. It also was the base engine in the Firebird Trans Am of 1969 and 1970. It basically was a 67-8HO version with a Ram Air cleaner assembly. It utilized the 288/302 duration camshaft and used the 744 cam in the earlier manual trans versions, later downgraded to the 068 version. It was rated at 366 bhp in the GTO version. The Ram Air 3 had used a similar block to the Ram Air 4 in that it was drilled for 4 bolt mains but used a cast crank and cast rods, and 2 bolt mains in 1969. In 1970 the casting number 9,799,914 Ram Air 3 4-bolt main block, also used the 4-bolt main caps on Ram Air applications. This engine also had the distinction of using the cast iron headers made famous on the original HO engine in 1967. Ram Air 4 The Ram Air 4 replaced the Ram Air 2 in 1969. All 1968 Euro 69 number 9,792,506 Ram Air 400 blocks have 4-bolt caps. The Ram Air 4 used the RA2's camshaft but lift in the RA4 was increased to 0.520 thanks to the use of 1.65 ratio rocker arms. The RA4, like the RA2 that preceded it, used round port cylinder heads. The RA4 also used a lightweight aluminum intake manifold that produced a weight savings of 10 to 15 pounds. From 1969 though 1970, the RA4 was available in both A-body and F-body form. While 1969 Euro 70 A-body RA4 production was low, only 100 RA4 Firebirds and 55 Trans Ams were built in 1969. RA4 Trans Am production jumped to 88 units built in 1970. Today, any high-compression round-port Pontiac is a highly sought-after car due to its low production and superior performance on the street and at the Strip. After RA4 production ended, Pontiac continued using its round-port cylinder head design in 1971. However, by this time compression had dramatically dropped off, marking the beginning of the end of the muscle car era. Ram Air V 303, 366, 400, 428. In 1969 Pontiac created several versions of their tunnel port engine, a special short deck version of the V8 for Trans Am racing and a 400 standard deck version. The factory also experimented with 366 and 428 cubic inches versions. The cylinder head was patterned after the highly successful Ford 427 tunnel port head. So large were the intake ports that the pushrods ran through the center of the ports via pressed-in tubes. 303, the revised engine had shorter connecting rods, smaller 2.5-inch journals, special tunnel port heads, and a solid lifter version of the 400's Ram Air 4 camshaft. It shared the 4.171-in bore of the 400, but with a 2.84-inch stroke for a displacement of 303 cubic inches. The short deck engine weighed about 40 pounds less than the 400, and had an 8,000 RPM's readline. The 303 program was promising, with race-ready engines producing 475 to 525 horsepower and slated for advertised ratings of 355 horsepower in the Pontiac Firebird and 375 horsepower for the Pontiac GTO. Concerns about emissions, the response of the automobile safety lobby, and the warranty implications of a high-revving street engine led to its cancellation. SCCA Trans Am Series general competition rules required an engine to be a production item, and required a production of no less than 250 units. The total number of Ram Air V303 engines produced is not known. Estimates range from the SCCA required 250 units, up to 500 units, with rumors of a handful of Ram Air V303s making their way into the Pontiac Trans Am production line. These engines are extremely rare and parts not readily available. The Super Duties equals SD 389 equals SD 421 equals SD 455 equals, available only in the 1973 and 1974 Formula Firebird and Firebird Trans Am. The SD 455 consisted of a strengthened cylinder block that included 4 bolt main bearings and additional material in various locations for improved strength. Original plans called for a forged crankshaft, although actual production SD 455s received nodular iron crankshafts with minor enhancements. Forged rods and forged aluminum pistons were specified, as were unique high-flow cylinder heads. A camshaft with 301/313 degrees of advertised duration, 0.407-inch net valve lift, and 76 degrees of valve overlap was specified for actual production engines in lieu of the significantly more aggressive Ram AIR-4 style cam that had originally been planned for the engine with that cam, but ultimately proved incapable of meeting the tightening emissions standards of the era. The very modest cam, combined with a low compression ratio of 8.4 and 7.91 actual, resulted in 290 SAE net HP. The initial press cars that were given to the various enthusiast magazines were fitted with the Ram AIR-4 style cam and functional hood scoops, a fact that has been confirmed by several Pontiac sources. Actual production test cars ran considerably slower and yielded 1/4 miles times in the 14.5 second per 98 miles per hour range in showroom tune, results that are quite consistent for a car with a curb weight of 3,850 pounds and the rated 290 SAE net HP figure that some sources suggest was underrated. Various Pontiac sources have emphatically stated that NO 310 horsepower versions of the SD 455 were installed in regular production cars. 1975 factory service manual lists the SD 455, but the SD 455 did not meet emissions for the 1975 model year and was cancelled. SD4 equals, while not a V8. The SD4 was the last in a line of high-performance Pontiac engines. A 2.7L 232 horsepower SD4 engine powered the 1984 Indy Fiero pace car to over 138 miles per hour during the race. The SD4 was never available in a production vehicle, however Pontiac's performance parts counter had all the SD4 parts available and one could garner a 2.7L 272 horsepower version and a 3.2L 330 horsepower version. All 2000 Indy Fiero replicas came with a 2.5L 92 horsepower Iron Duke engine. Pontiac HO engines equals 326 HO equals 350 HO equals. In 1968, there was also a 350 HO, which had an increased power with the addition of higher compression number 18 heads, a 4-barrel carburetor and matching intake that was also used on the 400 and 428 engines. There was also the addition of dual exhaust, and in the case of a stick-shift car, a slightly more aggressive cam. In 1969 the 350 HO was upgraded again with the addition of the 400 HO cam, commonly referred to by Pontiac hobbyists as the 068 cam. Also added was the number 48 casting number heads with a 68 cc chamber for higher compression, along with larger 2.11 inches and 1.77 valves. Free-flowing exhaust manifolds from the 400 Ram Air were used late in the model year. This was underrated at 330 horsepower. Many of GM's other divisions' 350s like Chevrolet, Buick and Oldsmobile and even the base SS396 were handily beaten by this little 350 high-output Pontiac. This may be today one of the most overlooked high-performance engines of the era, as it was overlooked by the buyers of larger 400 engines available in the day. It was basically a 350 with 400 heads to match the pistons. equals 400 tons per hour. 6.6 equals, in 1977 the 400 cubic inch TA 6.6 was created to fulfill the vacuum of the lackluster 76 455 HO, with improved flow cylinder 6X casting heads borrowed from the 350 yielding higher compression, specific camshaft and 3.23 gearing. It made 200 horsepower. The base 400 engines in 1977-78 produced 180 horsepower. In 1978 a new dual muffler exhaust was added making 220 horsepower, and provided the Trans Am and Formula Firebird with a breath of new life after some dismal performance years. The 4-speed manual transmission was also available behind the 400 tons per hour 6.6 and the 301 HO. The 400 tons per hour 6.6 did not live long. However, emission standards and fuel economy restrictions for 1980 model year doomed the power plant. The 301 turbo replaced the 400 tons per hour 6.6 in 1980, disappointing potential customers who were just getting excited about performance returning to Pontiac. The 400 tons per hour 6.6 Trans Am was the last of the performance cars available with a manual transmission, also yet another disappointment to potential customers. All 400 engines for 1979 were W72 versions and were last produced in 1978, after which time the tooling was dismantled. Some engines in 1979 vehicles may have been cast as early as 1977. W72 versions had chrome valve covers, base 400 versions had painted covers. The hood scoop decal distinguished which version of the engine was in the vehicle. The W72 cars had TA 6.6. The 185 horsepower 403 Oldsmobile powered cars as well as the base 400 cars had 6.6 liter on the scoop. It has often been mistakenly thought that in 1977-79 only the TA prefix on the hood scoop denoted that it was a Pontiac-sourced engine, and those ending in liter were non-Pontiac-sourced. Olds 403 were 6.6 liter decals. Chevrolet-produced engine was offered and had 5.0 liter on the hood scoop. 1977 was the first year for the liter designation on the scoop. Prior to that, it was shown in cubic inches. Equals 400 HO equals, this engine was first offered in 1967 as the third engine in the GTO and Firebird line. It produced 360 bhp, and had the cast iron headers. The camshaft was the HO cam with 288/301 duration. It was the top-of-the-line engine until the 400 Ram Air was introduced later in the year. This engine was offered as an option in 1967 through 1970. Equals 421 HO equals, first offered as an option in 1963. The 421 HO came in a 4-barrel engine of 353 horsepower and a HO version of 370 horsepower. Pontiac offered this to the public as a streetable version of the 421 SD. The engine came with 543,797 and 9,770,716 heads for the tri-power and special exhaust manifolds and a 7 hours cam with 292 deg intake duration and later 1964L with 288 deg intake, essentially the same as the 068 cam. By 1966 the HO version would be 376 horsepower. Equals 455 HO equals, 1970, the 455 HO designation made its debut in 1970. Rated at 360 and 500 feet per pounds of torque, it differed from the regular full-sized car 455 by large valve heads with smaller combustion chambers, and a larger camshaft. The 1970 455 HO was a conventional D-port engine. To simplify things, it was a late model year offering which was truly a high-output version of the 455 offered from the onset of the model year in all Pontiac's full-sized cars. 1971, the 455 HO moniker took on a whole new meaning with the introduction of the 1971 model year. Intended as a low-compression progression from the previous year's Ram Air 4 engine, all 1971 455 HO engines used a heavy-duty 4-bolt main block, round-port cylinder heads, Ram Air-style exhaust manifolds, and a 2-part aluminum intake manifold. The 1971 Pontiac 455 HO was Pontiac's first engine to receive a special 800 CFM Rochester quadrajet carburetor with specific jetting. The 1971 455 HO was rated at 335 horsepower at 4,800 RPMs and 480 feet-per-pound of torque at 3,200 RPMs. The 1971 455 HO was available in the Firebird and the GTO. 1972, the 455 HO moniker was again carried over, this time as a near-exact repeat of the 1971 offering. The only changes were the carburetors and the head castings. According to GM mandates, horsepower was now rated in net figures as opposed to gross, so on paper the 1972 455 HO appeared to have a significant drop in power, but in fact it was very much the same engine, and performance figures reveal this to be true. The 1972 455 HO was rated at 300 horsepower at 4,000 RPMs and 415 feet-per-pound of torque at 3,200 RPMs. The 1972 455 HO was available in the Firebird and the GTO. 1975, after the 1974 SD 455 was dropped, the 1975 Firebird's top performance engine was an L78 Pontiac 400 SID. Pontiac still offered the regular 455 in its full-sized cars, and after some public outcry a 455 HO package was offered for the Firebird's top-of-the-line Trans Am model. The 1975 455 HO was not simply an engine, but instead a package. This package consisted of 455 L75 engine, Borg-Warner T10 4-speed manual transmission, 3.231 posit traction differential, 455 HO callouts on the shaker hood scoop. The 1975 455 L75 was rated for 200 horsepower at 3,500 RPMs. The 455 HO package was only available to late model year Pontiac Firebird Trans Ams. The 1975 455 HO package received some negative press reviews as some buyers expected to see a return of the 1971 to 1972 engine. 1976, the 1975 late model year 455 HO package was carried forward and offered again on the 1976 Trans Am. But for this year the HO was dropped as a result of the negative press reviews from the model year prior. Ordering the L75 455 in the Pontiac Firebird Trans Am included the same packaged items as the previous model year, with the sole exception that the shaker hood scoop callout now simply read 455. Model year 1976 was the last year that Pontiac produced the 455 SID engine, and the final year of any 455 HO engine or package. 301 HO equals, while not high output fashion by the 1960s and 1970s standards and no HO moniker on the shaker hood scoop, the 301 did end up with a HO performance version, yielding 170 horsepower with only 4.9 L for the 1980–1981 model years. The 301 HO was the base Trans Am engine in 1980 and 1981. The modifications over the standard 301 4-barrel were designated the 301 Turbo 301T block. This included the ESC distributor and controller borrowed from the 301 Turbo, which allowed for higher timing without the penalty of engine-damaging pinging or pre-ignition. A large 4 inches ram air duct to the air cleaner, specific carburetor calibration for the 301 HO, and cam similar in grind to the 220 horsepower 400 from the 1978–1979 model year were also included. Unfortunately, there were no improvements in the casting number 01 small valve high-velocity heads, which would have yielded greater improvements in power. Pontiac experimental V8 engines 427 Hemi SOHC equals. This was a project started by Pontiac with the end goal of building a Pontiac 427 Hemi. Pontiac asked Mopper for help in designing it and making it work. Surprisingly, Mopper actually agreed and sent over several of the engineers that designed both the 392 and 426 Hemi. The goal of making a Pontiac Hemi succeeded but was never produced. Features: thin wall, cast aluminum block 4.342 bore x 3.75 inches stroke forged steel 6.625 rods 12-1 compression mechanical port fuel injection, large valve heads, 2.40 intake valve 2.00 exhaust valve, small valve high RPM 2.19 intake valve 2.00 exhaust valve, splayed main caps, head bolts tie into main caps. Head bolts do not pull on the cylinder wall causing distortion. Cam drive, fiberglass belt max RPM, 8,000 RPMs engine weight, estimated 550 pounds complete, dimensions, width 32 inches length, 32 height, 24.6, power, estimated 640 horsepower at 7,500 RPMs. Equals 421 2-valve SOHC equals 3-valve SOHC equals 389 4-valve DOHC originally made in 1966 for the Pontiac GTO. Pontiac 4-cylinder equals 195 equals. Perhaps the most unusual variation of the durable Pontiac V8 was not a V8 at all, but an inline 4. Nicknamed the Indy 4, created for the 1961 Pontiac Tempest, it was essentially the right bank of the 389, sharing most of its tooling and many of its parts. The bore and stroke of 4-1 are 16 in and 3-3 of 4 in were the same, giving a displacement of 195.5 cubic inches. This degree of commonality enabled it to be produced on the same lines as the V8, allowing substantial cost savings. A drawback was that the 195 weighed much more than a purpose-designed engine. At about 540 pounds, it was not substantially lighter than the 389. The 195 produced 110 horsepower at 3,800 RPMs and 190 lb-ft at 2,000 RPMs with a single-barrel carburetor, or 155 horsepower at 4,800 and 215 lb-ft at 2,800 RPMs with the optional 4-barrel carburetor. For 1962 a power pack option increased rated power to 166 horsepower. The Achilles heel of the 195 was engine shake. An inline 4-cylinder engine suffers from secondary imbalance. This is caused because of the 180-degree crankshaft. In this design, the two outside cylinders are always moving together and the two inside cylinders are doing the same. But due to geometry, a piston descending from top dead center will always move quicker through the first 30 degrees of crankshaft travel than a piston moving upward from bottom dead center, meaning that more mass is moving downward than is moving upward, causing a shaking in the vertical plane. Modern engineers consider the installation of twin counter-rotating balance shafts necessary for engines much larger than 122 GUI. The V8-based design of the 195 had no such balance shafts since costs prohibited adding them. The 195 was instead cushioned by flexible rubber engine mounts designed to isolate the engine from the rest of the car, and its forces were further dampened by the Tempest's unusual driveshaft. However, if the engine was out of tune or if a spark plug became fouled, the shaking overwhelmed the dampening of the mounts. A special high-strength timing chain was developed especially for the Tempest 4, since a standard chain would stretch and break rather easily from the inherent vibration in this engine design. The timing chain in the 195 was the same as the 389 initially. The upgraded Tempest chain also works on the V8 engines as a high-strength upgrade. As an aside, former Pontiac engineer Malcolm McCullough joked in an interview with Collectible Automobile magazine that he and his fellow engineers sometimes called the 4-cylinder Tempest a traveling fatigue machine. The 195 was dropped after the 1963 model year. See also, Pontiac Straight 6 engine, Pontiac Straight 8 engine, list of GM engines. References